Steven is a data scientist and proven leader with a history of delivering innovative, high-quality solutions to government and commercial sector clients. He has a strong background in technical leadership, project management, and business development, which he has successfully leveraged during his time at Booz Allen Hamilton to expand data science and operation research service offering to 30+ staff. He uses his technical experience in data science, operation research, cloud analytics, big data, modeling, and simulation, and database and software development in his role as a senior technical lead on a Department of Defense contract valued in millions of dollars. There you go.
Sorry. Oh, I see what happened. Is it okay if I put this on the display?
Yeah.
It's not. Right now it's giving the presenter view, and I just want the view. Yeah, if we just do new slideshow here, it should work. We just don't want it to do the presenter view, right?
So if you just take file.
But it's presenter view. How do we go to presenter view?
Well, it's fine. It's fine here on the screen. It's fine.
Yeah, but it's a problem down there. We really need to get rid of it. No, we can't.
All right, so go.
Do you know how to get rid of the presenter view? It's just words.
Sorry guys, we're trying to set up the video recording.
Yeah, I think it's weird. I don't know how to do it otherwise. Sorry. Well, we won't. Anyway,
All right, I think we're good. Okay, so in case you didn't hear, I'm Steve Knowles. I'm a data scientist at Booz Allen. I thought I would start today by telling a story about mosquitoes. And when I say that, and when you see this image, you probably instantly, your sort of mind drifts to summertime barbecues and getting eaten alive, as it were. But what we have to remember is mosquitoes are actually deadly predators in other parts of the world, in the sense that they're a well-known transmission vector for malaria. And so several years ago, in Kenya, there was a really bad malaria outbreak at a tea plantation. And the typical way of treating this is they go in and eradicate mosquitoes, and typically the outbreak will subside as the transmission vector goes away. But in this case, what would happen is they treat it, and the malaria would go away, and then a short time later it would come back kind of with a vengeance. And that process, that sort of cycle of treatment and reemergence continued and continued until some researchers gained access to cell phone records for the entire country. And they analyzed them, and they were actually able to start to see the movement of individuals around the country. And it turned out this tea plantation was in the footprint of a single tower, so it made all this pretty easy. And what they found was people that appeared at that tea plantation were much more likely to travel around the country than the average person. And in fact, many of them on the weekends traveled to an area in the northeast region of Lake Victoria. It was a popular recreation spot. It also happened to be a malaria hotspot. And so it turns out what was happening is people would leave the tea plantation for the weekend, contract malaria, come back, and then it would get passed around in a localized area of the tea plantation. And so the way to stop the outbreak was actually to treat the area in Lake Victoria, hundreds of miles away, to end the malaria outbreaks at the tea plantation. And so I share that story because I think it does a really good job of illustrating a couple things. The first is that process of starting with a really complex problem, getting a bunch of data, analyzing it, discovering some new patterns, and ultimately producing a set of actions to achieve some desired end state, in this case, stopping the spread of malaria. And that process from data to insights to actions, that is data science, right? And the other thing I think it illustrates pretty well is that data science really can change the world. I truly do believe that. I think we're getting to a place where we have the tools and the technology and the talent where we can really achieve change at a pretty massive scale. And I've talked about this a lot, and what I often say is data science is a multiplying force for social good. And what I mean is a small group of people sitting at computers with access to data can have a profound impact on the world around us. In fact, if you think about it, that group of people who might not be in the same room or even in the same city or even in the same country can be impacting the lives of people millions of miles away. And that can be fighting disease, fighting crime. I mean, the list goes on and on. And I call it a multiplying force because we're no longer constrained by the people we have on the ground in country, taking action. And that's not to say those people aren't important. They're hugely valuable. But what data science allows us to do is actually optimize their activities, right? Make better use of the resource we have. I mean, the malaria example is a great case, right? We still needed those people on the ground treating mosquitoes, but what we can do is help optimize their activity and make it more effective. And so in that way, we can suddenly really amplify the effect that we're having. And so as I say that, we're no longer constrained by the people on the ground, the natural question is, who is this new workforce for social good? And I would assert anyone, right? Anybody with the passion, the expertise, the wherewithal to help. And that obviously includes data scientists, right? I'm talking about data science for social good, but it can also be sociologists, economists, engineers, anybody with passion and some perspective to offer on a problem. And so that's really why we've seen the idea of data science for social good and crowdsourcing become inextricably linked as we think about these things. And so let's talk about crowdsourcing, right? This is not a new concept. It's been around for a long time. The earliest example is probably the Longitude Prize. The British government offered a cash award for whoever could come up with the best way to calculate the longitude of a ship. My personal favorite, the Mr. Peanut logo, was actually crowdsourced. And of course, the source of my timeline of notable events in crowdsourcing history, Wikipedia, right? Another classic example. And so crowdsourcing really does a couple things. And clearly from this timeline, we've seen that it can be applied to a variety of problems, a variety of domains, a variety of different problem types. And so it's not a surprise that we're using it for data science. And so when we think about data science for social good, it does a couple of things, right? The obvious one is it provides a workforce, right? There's nonprofits working heavily in these areas, but they don't have enough funding. We typically see these areas of white space. And in my experience, the data science community is so deeply passionate about applying our technical expertise to impact the world in a positive way that there really is no shortage of people ready to jump up and take action. The other less obvious thing it does is really provides a diversity of perspective to solving these problems, right? These are some of the most complex problems we face, right? Societal problems tend to involve people, which means they're inherently complex, right? We do crazy things, we act in unpredictable ways, and so these problems are really tough. And so a crowd provides you a huge diversity of different perspectives towards solving these problems. And I like to kind of illustrate that with a tangible example. And the really classic one is this stock and livestock exhibition in 1906. So at this event, there was a competition, guess the weight of an ox, and 800 people participated. And there was a researcher, Sir Francis Galton, that observed this and got really interested in it and collected all the data and actually ended up publishing a somewhat interesting paper, I guess, if you like to geek out on things like that like me, and shared his results. And what he showed was that the individuals did really, really bad, but the crowd did very good, right? The median guess was within 0.8% of actual, average was within 1 pound of actual. And so it's kind of like the classic example of the fact that the problem-solving abilities of the many are always greater than that of the few, or wisdom of the crowds, right, is the way it's generally described. And so I think that that does a great job of giving you a tangible example, driving that point home that crowds really give us a really interesting diversity of perspectives when we start talking about solving some of these societal challenges. So jumping back to my timeline of notable events in crowdsourcing history, there's two in particular that have really significance for data science and for social good. The first is 1999, the first hackathons were held, one by OpenBSD, one by Sun. And so hackathons are essentially where you bring together a group of people. The problem need not be super structured. It can kind of just be a broad problem area. Generally, they're in person, and usually a short duration, like 12, 24 hours a weekend, and pretty intensive. If you've ever been to one, people are sleeping on the floor. People really jump in and hack away at a problem. The early ones were really focused around just pure software development. Today, we see them applied to all different things: software, design, and of course, data science. And in the context of data science, these things are sometimes called data paloozas or data dives or hackathons. In fact, there's one in San Francisco that DataKind is doing this weekend. The other really big event is the launch of Kaggle in 2010. So Anthony did a really good overview of Kaggle earlier, obviously far better than I could ever do. But the short version, if you're not familiar, it's the premier online data science competition platform. They've got a community of 400,000 people worldwide now. It really was a game changer for how we think about crowdsourcing. I would say the big difference between hackathons and what Kaggle's doing is it has to be a much more refined problem, right? There's a very specific problem you're trying to solve. You're trying to create a very specific algorithm. Generally speaking, some kind of a predictive model or a classification model or something of that ilk. So it's a much more developed problem there. But still, you're catalyzing a big community of people around what can be a pretty challenging problem. And so I thought I would kind of give an example I've been involved with of each of these just to kind of illustrate what I'm talking about. The first one is a hackathon, an event we called the Hackathon for Hope. We held a little while ago in conjunction with the United States Holocaust Memorial Museum. And it really focused on probably one of the most complex societal problems there is, and that is episodes of state-sponsored mass killing or genocides, right? And so the Holocaust Museum is really unique in that from their inception, part of their mission, it's not just about cataloging the past, it's actually about taking an active role in preventing atrocities in the future. And so to that end, they've created something called the Early Warning Project. You can actually go online, find it. It's actually a crowdsourcing effort in and of itself. And there's various aspects to that, but the one of relevance here is what they call their statistical risk assessments. And so it's at a regular periodicity, they actually produce estimates of the likelihood of the onset of a mass killing in each country in the world. And the whole idea there is if we can arm the world with that knowledge ahead of time, we can actually take active steps to prevent atrocities from occurring. And so as they were getting ready to launch the Early Warning Project, we worked with them to hold a hackathon. It was a Saturday in August. We had 80 people come out, volunteer their entire Saturdays to this. And they worked on creating new models, identifying new data sets that could be used, ensembling approaches, data visualization, kind of came up with some ideas for data management framework, and ultimately produced a really good set of work products that we're able to share with the museum. And so that's kind of an example where we started with a somewhat open-ended problem, right? I mean, we had a degree of structure to it, but still it was somewhat open-ended. And we're able to catalyze a small group of people who work pretty intensely for a period of time on it. The next one I thought I would share is the National Data Science Bowl. Last year, Booz Allen and Kaggle sponsored the first ever National Data Science Bowl. And the vision for this event was really to catalyze the data science community around kind of a grand societal challenge. The challenge last year was predicting the health of the world's oceans at a speed and scale never before possible. And it turns out that a remarkably good indicator of ocean health are plankton, right? These little microscopic organisms. They're actually really, really susceptible to changes in water chemistry and temperature. And so you actually see the implications of changing ocean health on their population distribution and abundance before you see it in other ways. And so they're a really good early indicator of ocean health. And there's researchers at Hatfield Marine Science Center at Oregon State University that come up with a really interesting data collection methodology to do that. They have a camera they tow behind a ship, and it captures a stream of microscopic images. And to give you a sense of scale, over an 18-day cruise, and they don't collect images at night, or certainly not full-time during the daylight hours, but over 18 days, they collected 64 terabytes of data that is today manually analyzed by scientists. So it took a team of 5 researchers about 3 months to go through a terabyte of that, just to give you kind of a sense of timing. And so clearly something that doesn't scale. And so the challenge last year was, could you create an automatic image classification algorithm that could automate all that? And it turns out the answer is yes. In fact, we had 1,300 people participate, 15,000 submissions. It turns out that the accuracy the community achieved was actually far better than what any of the researchers thought was possible. And so they've actually taken that algorithm now and are implementing it, and Hatfield Marine Science Center will actually be using this for doing these very, very large scale studies of ocean health. And so not only did we help move the needle forward on sort of the study of ocean health, but beyond that, we actually introduced data science to the marine biology community who hadn't really traditionally been using it. And suddenly a bunch of researchers realized that this data science thing could help them as well. So what I kind of hope I've driven home here with these examples is kind of 2 things. I've proven out 2 things at this point. So, data science really can change the world. I started out with that. I said I truly believe it. Hopefully I've sort of convinced you with a few examples. And the other is crowdsourcing is the mechanism by which we can really effectively do that. And we're really seeing this happen, right? We're seeing crowdsourcing affect change, both big and small. I'm giving you some examples that are some pretty lofty societal challenges, right? But we're also organizing hackathons to do things like improve pet adoptions at a local animal shelter, right? So you can find any local problem too and catalyze a community of people around it. I mean, imagine what 10 data scientists in a room on a Saturday can accomplish. It's pretty amazing, really. But all this brings us to kind of the real crux of the problem, right? And that is data, right? We're talking about data science, you need data. And so think back to my original example, where I talked about people's cell phone data. And so sort of the natural question becomes like, how would you feel if that was your data? Right? And I was reading an article recently that made a really salient point, and he was talking about our field and data in general. And he said 10 years ago, when you mention data, people look at you in kind of a quizzical way and they don't really understand it. And we've seen this tide change over the last 2 years. If you encounter somebody in the street and tell them what we do and you mention data, instantly, without hesitation, they start thinking about their data, right? It's their health data, their credit card data, their social media data. And it's interesting the way our mind works that way, but it's really true, right? This is our data that's flooding into the digital world. I mean, just think about a couple of the facts I have up here. I'm certainly not going to go through all this, but 33% of people born in the US now have an online presence before they're even born in the form of sonogram imagery. 59% of 10-year-olds are social networking. So that's pretty remarkable, right? If you step back and think about that, the point I'm making here is that we have entire lives from birth, and in some cases before birth, all the way to death, now sitting in the digital world. And so I talked about how these societal problems are really inherently human, right? There's human behind them. So these are the data that are the most valuable for solving these problems. But these are also the data that we're the most sensitive about sharing, right? They are our data. And so as I said, think about that original problem. I mean, how would you have felt if that was your credit card or your cell phone data used to solve that malaria outbreak? Would you be comfortable with that? And at first blush, many people do say no, but actually there are cases where people are saying yes, right? So here's 3. The Personal Genome Project is cataloging the human genome, right? So you can contribute. So all of these, you can actually go right now today and contribute your data to help. So they're trying to build a big catalog of human genome data. And that one's interesting because it operates under open consent. So they recognize it's genomic information. We can't even try to anonymize that. So you're just consenting to share your information if you contribute. American Gut, so they're cataloging the microbes of the human gut. You can actually also donate pet microbes if you're so inclined, cats, dogs. Interestingly, their FAQ explicitly warns against donating alligator data. So I don't know if somebody did something stupid, but it's just kind of struck my fancy a little bit. About 3,000 people have donated there. And then go viral. So if you find yourself feeling impacted by virus symptoms, you can actually donate a swab. And the idea there is to track the spread of virus and impact the virus on communities. So these are places where people are saying, yes, I'm willing to donate my information for the greater good. And so as I reflected on this and thought about it, there's in aggregate about 5,000 people have contributed. in a country of 320 million. So the natural question is, why are more people not donating their data to benefit the greater good? And sort of as I reflected on that, I came to this conclusion that there's two things that are really preventing us from crowdsourcing data at scale. The ability to reliably anonymize data and the ability to control data, control our own data. And I'll kind of talk about each of these. So let's talk about data anonymization. This is a really hard problem that's been looked at for a really long time. It's nothing new, right? There was a pretty famous paper by MIT researcher Sweeney in the late 90s. And the big kind of headline conclusion there was she found that 87% of the US population can be uniquely identified with gender, date of birth, and zip code. Just those three pieces of information. And that number kind of floats down as you sort of add less specificity. So if you go from, say, date of birth to year of birth, the number drops. And then just a few months ago, a group of researchers at MIT released a study. They had 4 months of credit card transactions. And they found with just 4 spatiotemporal data points, they could uniquely identify 90% of the individuals within the corpus. And so then, your kind of mind goes to the next natural thing is, well, is it really that big of a deal? Just uniquely identifying an anonymous individual within a data set, is that really that big of a problem? And it actually is, and the reason is because you have to think about this bigger picture, right? It's not about that data set, it's about all the data sets that we have available. So another good example, in 1997, the Massachusetts Joint Insurance Commission decided to release medical records from the hospitals to a set of researchers with the goal of improving health outcomes and reducing health costs. And there's a lot of public outrage over this, and the Massachusetts governor stood up and assured everybody that the data were anonymized. So that same researcher, Sweeney, I mentioned on the last slide, decided to take the data and combine it with voter lists, and that's what you see in this Venn diagram. And you're seeing where this is going, right? She was able to uniquely identify a bunch of individuals, one of whom was the governor. And in a bit of a theatrical flourish, had the now identified governor's medical records hand-couriered to his office to prove a point. So the point here is anonymized does not necessarily mean anonymous. And this is a really hard problem. And as we're thinking about, I've anonymized the data set, I want to release it into the public realm, you have to also think about what are all the other data sets out there that could impact mine. And similarly, what are the data sets I'm going to impact by releasing my data? So this is a really hard problem. This is not going to be solved easily. But people are thinking about it a lot. And I thought I would share just one example of something we've been doing through some internal investment, working in collaboration with the Million Vets program. So the Million Vets program is attempting to build a huge corpus of genomic and health data. It'll actually be the biggest corpus of that kind of data in the world. They're targeting a cohort of 1 million veterans. It's completely voluntary, opt-in. And obviously what they want to do is share this really, really broadly with the research community. It's huge value in this data. But they want to do that while maintaining the anonymity of individuals within the data. So even though people are opting in, they do want to preserve their anonymity. And so the way we're looking at this is trying to implement a differential policy model kind of with a cloud architecture under it. And so the idea is this. You can query the data and get back aggregate results, but not individual results. So conceptualize it like you can ask a question of the data and get an answer back without getting all the individual data elements. And the way we're implementing that is by actually introducing controlled noise in the response. So the controlled noise prevents you from identifying an individual, but it's constructed such that it maintains the statistical properties of the aggregate. So again, I'm not asserting that this is an answer to this problem, right? This is not an easy problem. But what I want to illustrate is that we're working towards it, right? It's not just us. A lot of people are working towards solving this problem because we realize that it needs to be solved. Now, I tend to be optimistic about these things. I think the technology will get us there, right? So I believe one day we will solve this problem. And so that brings us right back to this other problem I mentioned, and that is the ability to control our own data. And so this is a fascinating thing if you sit back and think about it, right? I just talked about how it's our data, it's deeply personal, yet we have zero control over it, right? We generate all this data, we have no control over it. But I believe we are rapidly approaching a time where we will have control of our data, and we're all gonna have to make a conscious choice. Do we hold it tight, and protect it? Do we sell it, right? Because we could monetize our own data, or do we share it for social good? And so I think we're gonna have to make that choice one day. And that's a really fundamental shift in how we think about and interact with our data. I mean, it's completely different than what we do today. And I want to kind of drive that home. I mean, how different that really is. Imagine if you got this on your cell phone. Right, today we get the little pop-up, are you willing to share your data with Google? But imagine if at scale, like suddenly you start getting these on your phone. Hey, would you be willing to share your data with Hopkins researchers in trying to stop cancer? Would you be willing to share your cell phone records with people trying to stop a malaria outbreak? Like that is such a fundamental shift in how we interact with our data. But so just step and think about that for a minute. That is really pretty amazing. And I've talked about this a lot in kind of an abstract sense, and I always get people looking at me like BS. It's we're never going to get there. That's really hard. How could we ever do that? So we've been thinking about that as well. And one idea is the blockchain can actually be a mechanism by which you can do that. So blockchain, if you're not familiar, kind of came to fame with Bitcoin, the cryptocurrency. But we have to remember that Bitcoin is just something that sits on top of it. So kind of put Bitcoin out of your mind and just think about the blockchain. And essentially it's a technology that allows us to share information while maintaining our ownership and privacy, right? So the two big things we're talking about here. And in the context of cryptocurrencies, the information you're sharing is monetary value, but it could just as easily be enterprise health records or credit card transactions or social media data, right? They could all live in the blockchain. And so then the question is, well, why would companies do this, right? I believe we're going to compel companies to do this as a group, right? Because we do want to control our own data. And as soon as you get a group of people starting to do this, then you can monetize it. There's momentum behind it, and it sort of just goes from there. You could actually see a future at which we have, exchanges set up where people are buying data, you're selling your data, or you're donating your data for social good. So much like the last one, I'm not asserting that this is the answer, right? There is a lot of technological hiccups to actually trying to use something like the blockchain. And we're certainly not the only ones to think about it. There's a lot of big companies that are putting a lot of thought into how you could do this. But I wanted to share it because it is a tangible example of how you could start to go down this path. And I do believe we're approaching that future where we're going to have our data in a system like this, and we will have control of our data. And so as we think ahead to that future, we really are going to have a conscious decision to make, right? And what I hope kind of my goal for this talk, if I have achieved it, is I can get you to ponder this question, right? What would you be willing to share? Let's just say we've hit this future. I mean, would you be willing to share your medical records if it meant curing cancer? Or your cell phone records if it meant stopping a malaria outbreak? And if I've achieved anything today, I hope kind of at a quiet moment, you'll pause and ponder on this question, because we're all going to have to answer this question one day. And I believe to really move the needle as we talk about solving some of these societal challenges, which I think we have the power to do, we're going to need this data. And so it's going to be hard for us to say, give us your data, if we're not willing to share it ourselves. And even more than that, you're going to be sharing it with a crowd of people you don't know. The organizers of the event might not even know. That could be countries all over the world. And so that's what I want to leave you with. What would you be willing to share as we approach this kind of new future? So with that, I've kind of droned on long enough. If folks have questions or comments, I'm happy to take them. Yeah, in the back.
So I love that question. What would you be willing to share? Well, it's entirely context dependent, right? So personally, I'd be willing to share a lot of my medical data with researchers in basic science, but I wouldn't be willing to share it with my employees and insurance agencies.
Yep.
Change my premiums
Yep.
with respect to how healthy I am.
Yep.
Right? So there's actually a very nuanced argument.
Yeah, and that's actually what brought us to start thinking about something like the blockchain. If you look at, I think it's called Color Coin, but it's one of the I think that is an easier problem that we can solve in the shorter term than being able to guarantee true anonymization of data. That's a really good point. Yeah.
Last week, the new Canadian government, the new Prime Minister introduced again mandatory census that was skewed by Harvard, former Prime Minister. So the question I have to you is that this issue moves into one of the key dilemmas of this time, which is what is the role of government in making this happen. So what do you think it is, the role of government in maintaining anonymity, in making data mandatory or some data not mandatory? So, I mean, what do you think is that role?
Yeah, I mean, I guess here's my philosophy on it. I think we will get to this sort of idealized future faster if we get to a place where the population is compelling companies to implement these kind of data ownership mechanisms, right? Where we have better control of our data, right? Because that's a really hard problem, and it's going to be us that has to sort of force us to get there, because it benefits us the greatest, right? If we're suddenly taking ownership from companies that are currently monetizing our data, that becomes a sort of a big game changer. And so, I mean, certainly government could have a role, but I think what's going to get us there the quickest is if we, as a collective population, are compelling the implementation of these kinds of technologies. Yeah.
You showed the example of the request on, your phone saying, "Will you share your data
Yeah.
with this organization?" And I think that kind of falls under the umbrella of why the same friction that's why people don't donate to charity more often is they don't know enough about where it's going, the impact, and the kind of shadowy experience of donating.
Yeah.
What kind of, you mentioned obviously education, but what kind of efforts do you see reducing the friction in that kind of transaction?
Yeah, no, that's a really good point. And I should say I was just kind of trying to drive a point home with that of kind of a sea change in how we think about this. I think if we're really going to get to that future, we're going to need almost like a structured way to describe like a data usage in a way, right? In a way that, not to the point earlier, not a 10-page crazy document, right? But a very clear, here's what we need, here's why we need it, here's how we're going to use it, kind of a methodology. I think if we can establish that sort of a very easy to understand standardized format, this all becomes easier and becomes a lot more transparent. But until we get there, if you're trying to sort of unwind all this, it's going to get really hard, right? If you're going to get to that kind of a notification, you almost need to learn more button that gives you that very simple, easy to understand for a layperson, kind of an understanding. Anything else? Yeah.
You talked about basically you have, say, a database of genomic data, and you have, when you output to, say, people doing research, is just like a list of variants or some other kind of summary data. Is there a question of, how open are you going to be? Because effectively, if one team of researchers has access to, all the data in terms of which patient has which genomic sequence, is there a question? Is there a concern of one or a group of researchers in competition is going to be privileged due to access to more metadata or whatever?
Yeah, so I think in that one example I talked about, the vision would be the only person that has complete access, or the people that are organizing the study, essentially. The broader research community would just get some anonymized thing. So I think what you bring up is valid and something you have to think about, right? And that approach, the sort of ask a question, get the answer back, but not the underlying data, it's not going to work for every kind of application, right? Because in some cases, we truly need the underlying data. And I think we have to think